Okay, in this video, we're going to be looking at some of the homework problems in section 7.4. And we'll start with problem number 1, where we express the number as a percent. So here we got 4.61, and we want to convert that to a percent. Anytime you convert a decimal number to a percent, you want to move the decimal point 2 places to the right, as I'm doing here. So the decimal point in this case will be behind the 1, so you're going to have 461, and then you're going to add the percent sign behind it. So 4.61 as a percent would be 461%. Number 2, you're going to change the percent to a decimal number. In this case, we have 35%. And we want to convert that to a decimal. When we convert a percent to a decimal, we drop the percent sign. We move the decimal point 2 places to the left. Here in this case, this is a whole number. That means that the decimal point is behind the very last digit in that number. So we move the decimal point 2 places to the left. That means the decimal point will be in front of the 3. So it will be 0.35. So 35% as a decimal will be 0.35. Okay, problem number 3. What is 8% of 27? Okay, 8% of 27 is what we want to find out. Okay, the word of means multiplication, so we're going to take 8% and multiply it by 27. But first we got to convert 8% to a decimal. Of course, we change the percent to a decimal, a percent to a decimal by dropping the percent sign, moving the decimal point 2 places to the left. So that will be 0.08 times 27. Okay, and by the way, if you want to change a percent to a decimal, you can take the number and divide by 100. So 8 divided by 100 will be 0.08 times 27. And we can do this on the calculator if you want to. 0.08 times 27 will give me 2.16. Okay, so as a decimal, 8% of 27 would be 2.16. Number 4, Nathan received a 5% raise last year. If his salary is now $28,140, what was his salary last year? Okay, now we're going to have to work this out as an equation, or writing an equation. So what I'm going to do is let x equal last year's salary for Nathan. Okay, now he got a 5% raise. That means he received 5% of his salary from last year. So the salary that he got from last year plus 5% as a decimal will be 0.05 times whatever his salary was from last year will equal $28,140. Okay, so here's the equation that we're going to have to find out what x is. Now this x is like a 1x plus 0.05x. Combining like terms, you can get 1.05x is equal to 28,140. Now to solve for x, we divide both sides by 1.05, which means that x is equal to, now of course you can use the calculator, 28,140 divided by 1.05. That would be $26,800. So last year, Nathan's salary was $26,800. Okay. So this is the equation. This is the way we set up the equation, and then that's how we will solve for x. Okay, problem number 5. In problem number 5, during a sale, A dress decreased in price from $90 to $63. What was the percent of decrease? Okay, to solve this particular problem, we want to first find out what the amount of the decrease was. Okay, so we're going to do 90 minus 63. That would give us $27. That $27 represents the amount of the decrease. Now, to find the percent of that decrease, we take the amount of the decrease, divide that by the original price, which is $90. And then we're going to convert that to a percent by multiplying it by 100. So if I do 27 divided by 90, and then times 100, that would give me actually 30%. Because the percent of decrease is going to be 30%. So there was a 30% decrease in this in the price of that dress. Okay, problem number 6. A $270 suit is on sale for a 20% discount. What is the sale price of that suit? Okay, now first of all, let's find out the amount of the discount. So we're going to take $270 times 20% as a decimal, which is 0.20. Okay, because we're taking 20% of $270. So 270 times 0.20 would give us 54. So the amount of that discount was $54. Now we're going to take that $54 and subtract it from the 270. And that would give us the sale price. So 270 minus 54 would give us $216. So the sale price of the suit would be $216. Okay, so to do this, we take 20% of 270. That would give us the amount of the discount, that's 54. Subtract the amount of the discount from the original price to get the sale price. In this case, $216. Okay, problem number 7. An airline ticket costs $230 without tax. If the tax rate is 9%, what is the total bill for the ticket? And we're going to round to the nearest cent if needed. Okay, now, the tax rate, the amount of the tax is going to be 9% of the $230. So here we're going to do 230 times 9% as a decimal will be 0.09. Which will give you $20.70. That's the amount of the sales tax. Okay, the sales tax is going to be $20.70. Now we want the total cost of the ticket. To do that, we take the cost of the ticket, which is $230, plus the cost, well, the sales tax of $20.70. And in this case here, if we add those two together, we should get $250.70. And that $250.70 represents the total cost of that airline ticket. Okay, problem number 8. A baseball player gets 12 hits in 50 at-bats. What percent of the at-bats are hits? Okay, we're finding what percent, so I'm going to let X be the percent that we're finding, that we're trying to find, over 100. And that's equal to, now of the at-bats, he had 50 at-bats, so the number after the word of goes in the bottom. And he has 12 hits, so that 12 goes on top. Okay, so here we got X over 100 is equal to 12 over 50. Now we can cross multiply. You're going to get 50X is equal to 1200 divide both sides of this equation by 50. That means x is equal to 1200 divided by 50, or 24. And this will be 24%, because we're finding the percent. So 24% of the at-bats are hits. All right, problem number 9. An advertisement reads that if you buy 10 items, you get 50% off your total purchase. You need 8 items that cost $8 each. Which costs less, buying 8 items or 10 items? Okay. Now let's look at this here. You're buying 8 items that cost $8 each. So here, that's 8 times 8, which will give you 64. Now you won't get the 50% discount off the total price because it's less than 10 items. Okay, now for 10 items, you got 10 times 8, which will be 80. Okay, since we bought 10 items, we're going to get 50% off this total purchase price of $80. So 80 times 50%, or 0.5, which will be 40. And then you have 80 minus 40, which will be 40. Okay. So the final price, if you were to buy 10 items, your final cost would be $40. If you bought 8 items, it would just be $64. So it is more economical to buy 10 items in this case than it would be to purchase 8 items. Problem number 10. A tip in a restaurant is typically figured at 15% of the total bill. If the bill is $45, what would be the typical tip? Okay, so here we got $45, and we're going to multiply that by 15% of that total bill, which is 0.15 if you change 15% to a decimal. So 45 times 0.15 would be 6.75, or $6.75. So the typical tip would be $6.75. So you're just taking 15% of 45. Problem number 11 deals with compound interest. And these are just some spaces that you're going to have to fill in. In this case here, you're going to round to 2 decimal places as needed. And you're going to complete this chart. Here we've got the compounding period for semi-annually, quarterly, monthly, and daily. The principal is $1,000 on each one of these. And then your annual rates are different. Your time in years is different. Okay, and then you want the interest rate per period. Okay. So in this case here, if it's semi-annual, that means that there are 2 compoundings in a year. So that means that there are 2 compoundings in a year. If it was quarterly, it'll be 4. Monthly is 12. Daily, 365. So in this case here, the interest per period, 2 times 2, that's going to give you 4. I'm sorry. The interest rate, the annual rate is 4. Is 2 years. So 4% divided by 2. I'm sorry. Because here you got the 2 pay periods. 2 semi-annually compounding. So the interest rate per period, 4 divided by this 2, would be 2. So the interest rate per period will be 2. And then for 7%, 7 divided by 4 will give you the interest rate per period. That's 1.75. And then 18% divided by 12, because it's compounded monthly, which is 1.5. And then 18% at 365, so 18 divided by 365. Now we're going to round this off to 2 decimal places. This is going to be 0.05%, because we came up with 0.4, 0.049, 0.049, yeah. To 2 decimal places, it'll be 0.05. Okay. Now we got the number of periods, which is 4, which is 4, 16, 72, and then 18, 25. Now we want the amount of the interest. Okay. Now in this case here, we're going to have to think of that particular formula that we use to find the interest rate. Because we cannot use simple interest, we have to use compound interest in this particular situation here. And that's going to be this formula. A is equal to P times 1 plus R raised to the nth power. Okay, N is the number of periods. So in this column, this is your N, that's the number of periods. The R is the interest rate per period, so this is what R is, the interest rate per period. And of course your P is going to be your principal. That's the $1,000 here. So in this particular situation, using this formula, we're going to find out for semi-annual, we're going to find the total amount. Once we find the total amount, we can subtract that from the principal to find out what the interest is. Okay, so here, for semi-annual, if it's $1,000 here, this will be 1,000 times 1 plus R, the interest rate, that's 2%. As a decimal will be 0.02. And that's going to be raised to the power of N. N is the number of periods. That's 4. So here you got 1,000 times 1 plus, well actually 1.02 raised to the 4th. So here we're going to use the calculator. 1,000 times 1.02 raised to the 4th. Then hit enter. That would be 1,082.43. So this amount is $1,082.43. Now that represents your total amount. To find out the amount of the interest, we subtract 1,000 from 1,082.43. That would give us the amount of the interest, which is of course $82.43. So that amount goes there. Okay. Now let's see if it was compounded quarterly at 7%. In this case here, let's just say that this is semi-annually. Now this one is quarterly. In this case, it's going to be A is equal to P is still 1,000 times 1 plus the interest rate per period. In this case, for the quarterly, is 1.75. And that's raised to the N, which is the number of periods. That's 16. So here, this will be 1,000. And then 1 plus 1.75, that's 2.75 raised to the 16th power. So we have 1,000 times 2.75 raised to the 16th. Okay, that cannot be correct. Okay, let me try again. Okay, I need to change 1.75% to a decimal. That's my mistake right here. 1.75 as a percent as a decimal, that's 0.0175. So this will be 1 plus 1.0175. Okay, so we'll try that again. 1,000 times 1.0175 raised to the 16th. So this will be $1,319.93, rounded to two decimal places. You have to change 1.75% to a decimal, and that's why I came up with the wrong answer here. So it'll be 0.0175 plus the 1, which will be 1.0175. You raise that to the 16th power, multiply by 1,000, it will be this amount. So $1,000 compounded quarterly at 7% annual interest rate for 4 years will be $1,319.93. Subtract this amount from 1,000, well, minus 1,000, you'll get $319.93. That will be the amount of the interest. Okay. Now let's look at it if it was compounded monthly. Okay, so in this case here, A is equal to P, which is 1,000, times 1 plus R. 1.5% as a decimal will be 0.015, and it's raised to the n, which is 72. So 72 periods. So this will be 1,000 times 1.015 raised to the 72nd power. This will be $2,291.16, rounded to two decimal places. Okay, so that's the total amount there, $2,921.16. Now in this case here, we subtract 1,000 from the 2,921.16, and you're going to get 1921.16. Okay, and then compounded daily, $1,000 at 18% for 5 years. In this case, it's compounded daily. So we got this. A is equal to 1,000 times 1 plus 0.05%. As a decimal is this, 0.0005. Okay, because this is a percent. You have to move the decimal point 2 places to the left, so now you got three zeros in front of the 5. And that's raised to the 360, actually 1825. N is the number of periods. So that's 1825 as your exponent. And this will be 1,000 times 1.0005 to the 1825th power. Let's see what that would be. Times 1.0005 to the 1825th. That'd be $2,489.93. 2489.97. So for this one, compounded daily is $2,489.97. Subtract 1,000 from the 2489.97, you're going to get 1489.97. That's the amount of interest. Okay, so this is how you would complete that particular table using this particular formula. A is equal to P times the quantity 1 plus R raised to the n. Okay, You have to understand that your P is your principal. The R is going to be the interest rate per period. And then N is the number of periods. And how did they get the number of periods here? Annually is 2 periods in a year, so 2 times 2, that's going to be 4. Quarterly is 4 periods in a year. 4 times 4, that's 16. There are 12 months in a year. 12 times 6 is 72. 365 days for 5 years. 5 times that is 1,825. Okay? All right, problem number 12. Ernie Rolfe borrowed $3,000 at 6% annual simple interest. If exactly 1 year later he was able to repay the loan without penalty, how much interest would he owe? Now we're dealing with the annual simple interest, so we just use the simple interest formula. I is equal to P times R times T. Your P is your principal, which is 3,000, times the R. Your simple interest rate is 6%. As a decimal, that's going to be 0.06 times 1 year. So in this case, 3,000 times 0.06 times 1. That would be $180. So in 1 year, he paid $180 of interest. Okay. So that's the amount of interest that Ernie will owe. Problem number 13. A company will need $60,000 in 6 years to make for a new edition. To meet this goal, the company deposits money in an account that pays 7% annual interest compounded quarterly. Find the amount that should be invested to total $60,000 in 6 years. Wow. So in other words, he wants they're going to need $60,000 in a 6-year time frame. So no, T is going to be 6 years. And they're going to deposit money where the annual interest rate is 7% and is compounded quarterly. So if you do 7% divided by 4, that would give us 1.75% per period. 1.75% per period. And the number of periods they want 6 years, and it's compounded quarterly, so that means that there are 4 compoundings in a year. 6 times 4 would be 24. Okay, so we want to know how much their original amount is going to be. So in other words, we're trying to find out what their principal is going to be. Now we can use the formula A is equal to P times 1 plus R raised to the N. So the principal is what we're trying to find. Okay, they're trying to reach a total of $60,000. That's the amount. P is what we're trying to find, the amount that they should invest. And then 1 plus R. Now, the interest rate per period is 1.75. 1.75% as a decimal will be 0.0175. And the N is the number of periods, which is 24. Because if it's compounded quarterly for 6 years, 6 times 4 will give us 24. Okay, so here, this will be 60,000 is equal to P times 1.0175 raised to the 24th. Now, let's find out what 1.0175 to the 24th power is going to be. It's going to be 1.51644 times P. That's equal to 60,000. And then we're going to divide both sides by 1.5644. And you're going to get, now to the nearest dollar, it's going to be 39,566. Okay, that's the amount that this company should invest if they want to reach $60,000. If they put this money in the account at 7% annual interest compounded quarterly for 6 years. Okay. Problem number 14. How much money will there be in an account at the end of 4 years if $15,000 is deposited at 5% compounded quarterly, assuming that no withdrawals will be made? Okay, it is compounded quarterly, so that means that there are 4 compoundings in a year times the 4 years. That means that there are 16, actually 16 periods. Now we got 5% compounded quarterly, so 5% divided by 4 will be the interest per period. So 5 divided by 4 will be 1.25% interest rate per period. And we want to find out what that amount is. And this is, of course, the formula that we use. A is equal to P times 1 plus R, and that quantity is to the nth power. The P is your $15,000. And then times 1 plus. Now, 1.25% as a decimal will be 0.0125. And that's raised to the 16th, because N is the number of periods. R is the interest rate per period. 1.25% per period as a decimal will be 0.0125. So here I'm going to have 15,000 times 1.0125 raised to the 16th. Which will be $18,298.34. $18,298.34. That's the amount that will be in that person's account after 4 years, assuming that no withdrawals are made, on a $15,000 deposit at 5% compounded quarterly at the end of 4 years. Okay. And finally, problem number 15. It's going to be this. We have an amount of $2,000 deposited in a bank at a rate of 8% compounded quarterly for 5 years. The rate then increased to 9% and was compounded quarterly for the next 5 years. If no money was withdrawn, what was the balance at the end of this time? Okay, so here we need the interest per period. That's 8% And it's compounded quarterly, so there are 4 compoundings in a year, so 8% divided by 4% will be 2%. And then we want the number of periods. If it's compounded quarterly for 5 years, that means 4 times 5, that's 20. So that means that there are 20 periods that we're dealing with. And the formula again is going to be A is equal to P times 1 plus R raised to the nth power, which means the P is going to be $2,000 times the quantity 1 plus R is the interest per period, which is 2%. 2% as a decimal will be 0.02. That's raised to the 20th power. So now you got 2,000 times 1.02 raised to the 20th power. So now to the nearest penny, it'll be $2,971.89. Okay, so that's the amount in this account after the first 5 years when it's compounded quarterly at 8%. But then it increased to 9%. So now the interest rate per period is this, 9% divided by 5, which will be 1.8%. And it's going to be for the next 5 years. It's still compounded quarterly, so the number of periods is still 20. And we're still going to use this formula. A is equal to P times 1 plus R, that quantity is to the nth power. But this time, we're going to use the amount that was in the account at the end of the first 5 years, which is $2,971.89. And then that's going to be multiplied by 1 plus. Now the interest rate per period is 1.8%. So as a decimal, it'll be 0.018. And that's raised to the nth power. Still compounded quarterly for 5 years. 4 times 5 is 20. So now you got 2971.89. That's multiplied by 1.018 to the 20th power. And that will give you okay, did I do something wrong here? 9% at 9% for the next 5 years. That's 1.8%. And then you got 1 plus R raised to the n. I used 2971.89 because that's the amount in the account at the end of the first 5 years. Okay, so let me try this again. 2971.89 times 1.018. And it's raised to the 20th power because of the 4 times 5. That would be 20. Okay, this is pretty much what I come up with, $4,246.08, which is the amount that will be in there at the end of 4 years, at the end of all that time when it's increased to 5%. So this should assist you with some of the problems in section 7.4.